Okay, today we are going to work on solving multi-step inequalities. And to solve multi-step inequalities, we basically do the same thing we do when we're working with multi-step equations. We just work backwards, undoing the operations, first undoing addition and subtraction, and then undoing any multiplication and division. The only difference is that when we solve multi-step inequalities, we have to remember our rule for inequalities, that if you multiply or divide both sides of an inequality by a negative number, you have to reverse the inequality sign. All right, so let's try this first one. First of all, I see that I have two steps here, so first I'm going to take the 10 off of this side. I'm going to undo the 10. So I'm going to subtract 10 from both sides. 25 minus 10 is going to leave me with 15. And I have not multiplied or divided by a negative number, so I'm just going to bring my less than sign down. And when I took this 10 off, that left me with negative 5a over here. All right, my next step is to separate the 5 and the negative 5 off of here. So I'm going to divide this side by negative 5, and I'm going to divide this side by negative 5. Now, if you noticed, I now have divided both sides of the equation by a negative number, which means I'm going to have to flip my sign. So instead of it being less than, now I'm going to have greater than. My 5's are going to cancel out. I'm going to have an a, and 15 divided by negative 5 is going to give me negative 3. So the answer to this multi-step inequality is a is greater than negative 3. And if I wanted to graph that, I would draw a simple number line, and I don't need to draw every single piece. I'm probably just going to put on negative 4, negative 3, and negative 2. And all of my solutions for this inequality are, the a's are all greater than negative 3. So it's the numbers that are greater than negative 3. So anything in here is going to be a solution to this inequality. And since it is not less than, or greater than or equal to, it's just greater than, I don't need to color this in. I'm going to leave it open. All right, let's try the next one. Okay, on my next one, I have some division, but it's still a two-step inequality. So my first thing I'm going to do is take the 9 off of this side, and whatever I do on one side, remember, I have to do on the other side. So now I'm going to have 5 minus 9, which is going to give me negative 4. Copy my sign because I haven't divided by a negative number, I've just subtracted. And the 9's are gone, and now I have m over 2, or m divided by 2. Now, to undo the m divided by 2, I'm going to use the inverse operation of division, which is multiplication. I'm going to multiply that side by 2, and I'm going to multiply that side by 2. Now, I've multiplied by a positive number, so there's no need to reverse the sign. These are going to cancel out, and I'm going to be left with m is greater than or equal to negative 4 times 2 gives me negative 8. And that is the solution to that multi-step inequality. Now this next one is a little different. It has grouping symbols, and we worked with them a little earlier in the chapter. And what we want to do is get rid of the parentheses before we begin to solve this inequality. So we're going to use our friend, the distributive property. So we're going to just sort of pass that 2 out among these numbers in the parentheses. So 2 times n is 2n, and 2 times 3 is going to give me 6, and that's all going to be less than negative 4. And the next step is to subtract 6 from both sides. We're starting to isolate that variable at n. So what I have left over here is 2n is less than, I have to do negative 4 minus 6. You have to remember when you're subtracting these to remember your integer rules too. So we're going to keep, switch, change. Negative 4 plus negative 6 is going to give me negative 10. Alright, now it's time to get the 2 off of this side, and I'm going to use division for that. I'm going to divide this side by 2, and I'm going to divide this side by 2. Again, I've divided by a positive number. There's no need to reverse the sign, so I'm just going to keep my less than sign there. This side is going to give me n, and negative 10 divided by 2 is going to give me negative 5. So my solution for this inequality is n is less than negative 5. I have one last example here. If you remember in the beginning of the chapter, we worked on inequalities with variables on both sides. So before I can do anything with this, just like with the equations, I need to get all of my c's together on one side and all of my constants, in this case, the variables on one side and the constants on the other side. So the way I like to do it is to get my expressions, my numbers with variables together first. So I'm going to take the c off of this side by subtracting it. And remember that there is an invisible 1 here. All right? And what that leaves me over here is negative 1 is less than, and 3c minus that 1c is going to leave me with 2c plus 5. Okay, so I've got my terms with variables together. Now I need to get my terms with constants together. So instead of plus 5 here, I'm going to have minus 5 there. I subtract 5 on that side. I need to subtract 5 on this side. Those will cancel out, leave me with 2c. And again, negative 1 minus 5. I need to remember my integer rules. Keep, switch, change. Negative 5 plus negative 1 gives me negative 6. Is less than 2c. Now, I need to get the 2 off of this side to separate. I'm going to divide them. Divide both sides by 2. Gives me c. And negative 6 divided by 2, negative 3. Now, depending on which you move to which side, this may be reversed, but either way, you should end up with negative 3 and c. And on the last page, I have a couple for you to practice. 3x plus 4 is greater than 31, and negative 3 times b minus 1 is greater than 18.